All right, kids, we're back with our second part of our problem set number 27. Yesterday, you should have gotten through most of part one, maybe just halfway through the problem set. That's what we did in our class. So you hopefully finish that up and you're on to this one. Now, this might be something that you could do independently. You might want to give it a shot on your own. Teachers, you can pause and then check for understanding as you go around. So I'm going to go through this. Feel free to pause this at any point and preset the kids at all as you're going. So let's get started. Model using place value disks and record using the algorithm. So same thing we've been doing. Now there's less space here, so I have to write a little bit smaller actually, okay? So my disks are over here, so I have to write my T-chart. Okay, just like that. And I've got ones, tens, hundreds. Just like that, okay? And what I have to do is put my disks in and I'll write my algorithm out. So 600, 1, 2, 3, 4, 5, 6. Remember I put my disks in rows of 5. Then 5 tens, see the 5? 1, 2, 3, 4, 5. So 655, 5 ones, 2, 3, 4, 5. Good. And over here, I'm doing this as 655 divided by 5. I know there's not going to be a remainder here because 5 will fit into this evenly because it ends with a 5. See that? All right. So here we go. I need to now take my divisor and I need to make 5 groups down here. So we need to write these kind of thin. So I have to be very careful here. This is going to separate them up. There's 1 group, 2 groups, 3 groups, 4 groups, and 5 groups. Okay. I'm going to number them so that makes it easier for me to see the groups. There's the 5 groups that I need to divide them up into. See, because that's my 5 right there. All right. Great. So let's get started. I'm going to change colors. My pens. Okay. Put my superpower pen to get to work. So over here, I've got 6 divided by 5, or how many 5s fit into 6 without going over. And I know my answer here is 1, right? And let me show you what that looks like over here. That looks like, see, 1 in each one. Taking my 6 and dividing it into 5 equal groups. Good. And it looks like I'm left with 1 left over, okay? So that's what we're going to show here. I have to show that remainder over here. Let me show you what that looks like. 5 groups of 1 is 5. So we see 1 times 5 is 5. And I subtract that to get 1. So there it is. See how I subtracted these by crossing them out? That's what that subtraction means here, okay? So I'm left with 1/100. That's why I'm writing it under the hundreds place. Now, the problem's not over. I can keep going. What I need to do now is change these hundreds out into tens. So I'm going to decompose this 100 into 10 tens. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Great. 5 and 5 make 10. That's what I do by doing this, dropping this 5 down in the tens place to show that I'm doing 15 tens right now, okay? So now my new division problem is 15 divided by 5. So, or how many 5s fit into 15 without going over? And the answer here is 3, right there. So each one of these is going to have 3 disks in it, right? So I'm going to say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Take 5 more. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each group has got 3 in it, and that's what that 3 stands for. There's 3 tens in each of these groups. 1/100, 3 tens. Now, I prove it, okay? I need to show that there's no remainders here. What is 5 groups of 3? That's 15, you see that? 3 times 5 is 15. and I subtract to show that there's 0 left over. There's 0 remainders. I used them all, okay? Now, I move on to my ones place. I'm over here. So I had to drop this 5 down here. And I asked myself, what is 5 divided by 5? Or how many 5s fit into 5 without going over? And the answer, of course, is 1, right? Let's show that one over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just like that. Each group got its own little disc, and that's it. So 5 groups of 1 is 5, right? 1 times 5 is 5. Subtract, I get 0. And that 0 shows I don't have any remainders. So my quotient, 100, see that? 100, 100. 3 tens, 30, 1, 1. Each one has the same amount. So 5 groups each have 131. On to the next one. Okay. This one is 726 divided by 3. Same procedure. I'm going to write a little bit smaller, a little bit neater here, okay? I have to be very careful because I don't have a lot of room here. But my T-chart, ones, tens, hundreds. Over here, let's write my algorithm out. 726 divided by 3. Okay, that's my divisor. Okay, good. So here, let's give it a shot. 700s. 1, 2, 3, 4, 5, 6, 7. Remember, rows of 5, and this, this obviously is just 2 extra. Tens, there's 2 tens. 1, 2. And then there's 6 ones. 1, 2, 3, 4, 5, 6. Great. Now I'm splitting this into 3 groups. So down below here, I need to show 3 groups of discs that I can go. So there's my divisor, it's 3. So I'm going to draw my rows here. 1 little group, 2 little groups, 3 little groups. And I like to number them. Just like that, so I can see my 3 groups. All right, now it's time to switch color pens into my superpower pen. All right, so I'm going to show this 3-digit division here, okay? Start my hundreds place with 7. What is 7 divided into 3 groups going to be? 7 divided into 3 groups. Or if I ask myself how many 3s fit into 7, the answer is 2, right? If I have 7 split into 3 groups, I'm going to have 2 in each group. But I'm going to have a leftover, aren't I? Let's show what that looks like here. 1, 2, 3. So I'm going to take 3 discs and put them in here. I'm going to take 3 more discs, because I have enough, put them in there. And there's my 1 left over, right? Because 2 groups of 3 is 6, right? Or 3 groups of 2 is 6. See, 3 times 2 is 6. Subtract, and I get 1/100 left over. There it is. Okay? Now I'm ready to move on to my tens. All right, so I drop down this 2 to make 12 tens. Over here, I got to decompose this hundreds into 10 tens. Okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 10 there and 2 there. That's 12 tens, and that's what that 12 stands for. Okay? It's 12 tens. So now 3 fits into 12. Or if I want to say 12 divided by 3, because this is 12 split into 3 groups. How many am I going to get? If you know your math facts, this probably comes right to you. So 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yep, there's 4 in each group. Great, no remainders, like that, that's nice. So I put 4 tens in each group, so this 4 needs to be right over the tens place here. 4 times 3 is 12, right? Checking my work, I subtract, I get 0 left over. See how there's none left here to decompose? Perfect. Now I'm onto my 1, so I need to drop my 1s down here. 6 ones. What is 6 divided by 3? You're right, the answer is 2. I'm going to end up with 2 discs in each one. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. There we go. There's 2 ones in each one. Let's check it. What is 3 groups of 2 equal to? 6. two groups of 3, 6, subtract 0. Good. No remainders, no remainders. 242. Let's check each group. 242. 242. 242. There are 3 groups of 242 right there. All right, All-Stars. Last one. We can do this. All right. 688 divided by 4. Make my T-chart. Ones, tens, hundreds. Okay, and let's do my algorithm over here. It'd be 688 divided by 4. Okay, now I'm going to take a look here and see what we got. I'm going to switch colors. Nope, can't switch colors yet. I'm getting ahead of myself. I'm too excited, I want to do this. 688, 600s. 1, 2, 3, 4, 5, 6. 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. And 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, my dividend is 4, so I need to show 4 groups below this. So I have to be very careful not to make my groups too big, okay? All right, so I'm going to start here in case I have to regroup. There's 1 group. There's 2 groups. There's 3 groups. And there's 4 groups. So 1, 2, 3, 4. Kind of got narrow there, but I can make that work. Now I'm going to get my superpower pen out. All right, here we go. Starting off, start in your hundreds place. I have 6, and I need to divide them into 4 groups. All right, so 1, 2, 3, 4. Each one gets 1, right? That's easy. Now, I've got 2 hundreds left over, but 4 groups to split them into. I can't do that. I'm going to box these two because I got to regroup these. Let's show what that looks like over here. 6 divided by 4 would give me 1 in each group. Or I could say to myself, I like doing it this way. How many 4s fit into 6? I know 1 4 can fit into 6. Because 2 is 8. 2 goes higher than 6. So 1 times 4 is 4. I subtract that, I get 2. And there's my 2 remainders right there. You see that? Those are my 2 hundreds left over. Now what I need to do is take these hundreds and make them into 20 tens. See, if I drop this 8 down, you see the 8 tens I have here? I end up with 28 tens. I need to show 28 tens here. Okay, so that means I've got to fit in 20 circles here. So I'm going to be very careful when I write these out, and I'm going to write small so I can fit them all in. So 1, 2, 3, 4, 5. I'd also like to keep them in the same row like this, a column. You see that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I barely fit it in. If I needed to, I could go over here. That wouldn't be a bad thing. But when you get a lot of circles in that tens place, man, it can get really confusing, okay? So let's do this. Let's do this part first so we know how much goes into each group. Now I've got a new division problem. What is 28 divided by 4? I know this. I know my multiplication facts. I know that it's 7. So I need to have 7 circles in each one. So I'm going to do that over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Kind of doing this differently than I did before. Kind of made a mistake, to be honest with you. But I'm going to continue to do it. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, doing it over here really helped me out with this. See how confusing that got with all those discs? Okay. So I've got 7 in each group. 7 and 7. 170. Let me prove this first, that there's no remainders. See, there's no remainders left over. I crossed them all out. 7 times 4 is 28. Proving it right now. Subtract, I get 0. There's no 10s left over to decompose. See? 0, nothing. This boxed. I bring down my 8 ones, 8 divided by 4. Or how many 4s fit in the 8 without going over? And that would be, what, 2, right? 2 times 4 is 8. And then I subtract that and I get 0. See what that looks like here. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. No remainders, no remainders. My answer here is if I take 688 and divide it into 4 groups, I'm going to end up with 172 in each group. See? 172. 172, 172, 172. Just like that. And that concludes problem set 27. All right, we're going to do the same thing on Monday. Hopefully you have be a little bit more independent, that you can do this yourself with teachers checking in with you. Don't worry, we'll be here for you. We don't want you to get upset or fail this in any way. But your job is to go home and think about the stuff that we've done. Your job is to make sense of it, all right? Ask questions, all right? Come up to the teacher and say, hey, can I have some more practice with this, all right? And if you need to, this lesson and all the other lessons that we do are all on your Google Classroom if you want to watch it again, okay? Great job. Have a great weekend, kids. See ya.